Okay guys, so in this video we're going to be talking about the product of powers, and this is really 10.2. Hopefully your notes say that. These are Math 8 notes. And what we're looking at is the product of powers. So something we kind of talked about in the previous video is that if you had some number, let's say 4 to the second, and then 4 to the third, that's going to come out to 4 to the fifth. So what's going to happen is you're going to add the exponents and keep the base. So the way to remember this, the best way, is to just remember the following. Keep the base, add the exponents. Keep the base if it's the same, and add the exponents. The bases, of course, have to be the same. In my example, my red circles are both 4. The base is 4. So you just simply add the exponents. Does that make sense to everybody? So that's what we're kind of trying to do here. So let's talk about that, do a couple examples. Do it. So let's try that a little bit, keeping the base and adding the exponents, and see what we can do. So here's basically the rules. So let's try if we had an example of 5 to the second times 5 to the third times 5. What would that be? So there's one little thing I haven't really told you too much about, is that if you don't see an exponent there visually, what do you think you fill that in with? A 1, exactly. So there's an imaginary 1 here, and correct, we want to keep the base and add the exponents because it's multiplication. So it's going to be to the 6th power, and we're going to keep the base. In other words, it's going to be 5 to the 6th. And you don't necessarily need to do 5 to the 6th out because that's a huge number. That's a lot of work. So we're good with that. So that's basically how the product of powers works. When you're multiplying two exponent expressions, you keep the base and add the exponents. So we did a couple of these yesterday. We had this problem and this problem. This one's a little bit weird here, B, because they're not really the same base, but I guess what we could say, ideally could you say this is to the 1st power still? I would say yes, and we'd have -5 to the 7th power then. So that'd be the answer to that one. And then you probably know the answer to this one, so if you want, you can pause the video and try this problem. But if not, we can probably just come up with the answer pretty quick. So I'd encourage you to think about what this would come out to if we keep the base and add the exponents. X to the 10th power is what it is, because 3 plus 7, right, that's these numbers right here, is 10. So keep the base, add the exponents. So that's exponent rules in a nutshell, and now we're going to talk a little bit about some different types of things, maybe some division of exponents, maybe some things where it's a little bit trickier. So let's see what we've got here. I think we want to know how we can divide two powers that are the same base. Two powers that are the same base. So what I would encourage you to just think about, if you're trying to divide two powers that have the same base, let's say we had, I don't know, I'll just write an example. Let's say we had example. This is not on your note paper, so if you need to, just write in the margin. We're not going to be doing a whole lot more, so it's okay to just kind of tag it on. So this is x to the 9th divided by x to the 2nd. Now we know that with multiplication, if we're multiplying, right, we keep the base, and we add the exponents, right? That's important. So if that's what we do for multiplication, what do you think that maybe we do for division? Just think about that for a second. Division would be keep the base and think about that for a minute, okay? And I don't want to give the answer right now, actually, because I want you to think about it, and I actually want you to learn about it a little bit on your own. So we're going to kind of wrap it up there. I might just show you just a couple of things where I've mixed some rules together, so maybe just a couple more examples, and then I'm going to teach you how to do division at a later time, really. But I just wanted to throw that idea out there and not give you the answer to that blank right this second. But we'll come to it later this class. So here's a couple more things, just some examples. I know I changed gears. I know I kind of got you thinking about that, but now I want to show you just two more things. Let's say that we have mixed some things up. So let's say we had 6 times 2 to the 3rd plus 2 times 2 to the 6th. Okay? Now this is getting a little weird. We got a couple different things going on. So we know PEMDAS says to do the parentheses first. We don't see any parentheses. Then exponents, yes.
Would you combine the numbers with the exponents?
What I would do here is I would just focus on multiplication first of exponents, and I would say that's 2 to the 1 plus 6 is 7, and I would call it. And then I would come down here and bring everything else down. Now this is addition. You want to think that you can keep the base and add the exponents, but you can't. You only do that for multiplication. So PEMDAS would say, I think you just have to do out this whole blue part now. So exponents still say that this is going to be 6 times 8, because 2 to the 3rd is 8. And I'm only making you do that out because I kind of know that's how this problem is going to work out. And then I'll keep this all the same color, plus 2 to the 7th, right? We're not going to do 2 to the 7th out. It's just too big. But 6 times 8 is 48. So we have 48 plus 2 to the 7th. So it's simplified. It's not simplified completely, but it's a better way of looking at it, right, than expanding out 2 to the 7th. That's just too much. Let's try one more. Hopefully that made some sense to you. So all I did was a couple of different rules at the same time, old rules and then the exponent rules all together. Let's talk about one more example. So this one will be, let's say it's 3 to the 2nd times 2 to the 2nd plus 5 to the 21st times 5 to the 3rd. So let's just think about what we can do here. PEMDAS says parentheses, we have none. Exponents. So what I do in this situation is I say, are there exponents with similar bases? So why don't we focus on those for a second? Why don't we use the rules, the new rules that we know, instead of multiplying 21 times, that number's way too big to write down. So it's 5 to what power? Yes? Yeah, 5 to the 24th, exactly. So that's an ugly 5, so let's fix that. We got 5 to the 24th is the answer to that. And now let's just focus on this right here. Can we do anything with that? Can we use a property, or should we do something different? We can't really use the property of keep the base, add the exponents. We can't do it because they're not the same base. You can't keep the base. You wouldn't know which base to keep. You wouldn't know whether to keep the 3 as the base or keep the 2. So you actually have to do the math out. 3 to the 2nd is pretty straightforward. What is 3 to the 2nd? 9. So we have 9. And then here we have 2 to the 2nd, which is simply 4. And those are multiplied, and then we're adding that 5 to the 24th. Take a look at that, see, make sure it makes some sense to you. All we're doing is just working it the best we can do. Of course, 5 to the 24th we're not going to multiply out, but 2 to the 2nd we can, right? So sometimes you might see, you might not know whether to multiply it out or not. Use your judgment usually. Let's finish it up. Well, we just need to do 9 times 4, which is 36. So it's 36 plus 5 to the 24th. That's what we're looking for. We're not doing 5 to the 24th out, no way. So we're going to call it good there. So hopefully this video has helped you to tie a couple of the properties together, got you thinking about the division property, and we'll kind of wrap it up from there. And we'll explore those things at a later time. I will see you in the next video. Keep it short and sweet. Peace.